Alright, Rebels, error problem here. It's kind of like the one you might have on your quiz tomorrow. This one, we're going to use e to the x as our function. We're centering it at x equals 0. We're traveling as far as 10 in either direction. We know the further you travel from where you're centering the thing, the more inaccuracies you're going to introduce into it. Alright, so what we're going to do here, work this thing out. We're going to get our, we're going to say the error here is less than. Alright, we're going to set up our formula here. Alright, if we're looking at the 100th Taylor polynomial, it's the 101st derivative that we'll be focusing on. So what we have to do here is we have to find the 101st derivative of this function. Alright, we've got to maximize this. Okay, the 101st derivative needs to be maximized. In the denominator, we are going to have our factorial. It's going to go in there. And then over here in the parentheses, you're going to list how far you're moving from where you're centering the thing. So in this case, we're moving as far as 10. So we got 10, subtract where this thing is centered, which is 0, and we're going to raise it to the 101st power. Alright, and in the denominator, we're going to have 101 factorial. Okay, now let's talk about the numerator. We want to maximize the 101st derivative. First of all, what is the 101st derivative? Well, the derivative of e to the x is e to the x, and the derivative of that is e to the x. So 101st derivative, f of 101, if you will, is e to the x. Now, where is e to the x maximized? Well, maybe you want to picture the e to the x function, and it looks kind of like this, right? So the further you go to the right, the higher up we're going to go. So we want to maximize this, and on our interval -10 to 10, it'd be maximized at x equals 10. All right, so we're going to use that for z. So if we rewrite this, we're going to say the error is less than e to the 10th power times 10 to the 101st power all over 101 factorial. And then you'd want to use your calculator to finish this off. No one can do that in their head. And let me punch it in right here. Looks like I got about 2.33 times 10 to the -55th power. And I don't know about you, but that's pretty darn accurate to me. And the reason this is so accurate is because we took, over 100 derivatives. The more derivatives you take, the more accurate your estimate is going to be. The closer our interval is to where we're centering it, the more accurate it's going to be. If our interval, instead of going to 10, only went to 1, we would be even more accurate, obviously. But pretty accurate. So that's a little summary on Lagrange error bound.